All right, hello everyone, welcome. So in this video, we will be introducing hypothesis testing overall, and for this particular example, we're going to talk about hypothesis testing first when we just have a single categorical variable of interest, much like what we worked in the previous section. So we're starting the section 5 note packet. As usual, the beginning gives the learning outcomes for the section, but we're going to jump straight to the bottom of page 2, which has the example we'll be using for this first part of the note packet. So the example says that we're thinking about this video game called Super Smash Ultimate. It doesn't really matter whether or not you know this game. The most important thing is that there are these matches are sometimes played with four people. And so we want to test whether or not there's statistical evidence that the proportion of times, jumping up to page 3, that we win is different than the proportion of times we would win if the matches were decided by random chance. So that is the question that we're setting up for this hypothesis test. What we do to collect data to answer this is that in each of these 54-person matches, we record whether or not we won the match. And so we end up finding that we won 16 of the 50 matches. Okay, so this page sets us up and we'll partially review some stuff that we talked about in previous sections. We're going to start by writing what our variable of interest is. And so our variable of interest is whether or not we win a match. And so again, we're thinking about what we would record for one particular case. We would just record whether or not we won. It has, so it's categorical, and it has two levels, because either we won the match or we lost the match. So that sets us up for this hypothesis test for a proportion when we're in this particular setting. Something you can think about then is that if these matches were actually decided by random chance, and there's 4 people playing, what proportion of the time would we expect ourselves to win? And the answer to that would be a quarter of the time, or 0.25. So if there's 4 different people playing and the matches are actually decided by random chance, we'd win about a quarter of them. If we were actually better than our friends at this game, we would expect the proportion of times that we win to be much, and I'm just going to put much in quotes, so much higher than 0.25. So that should make some intuitive sense. If we're better than our friends, we would expect to win more and much more than a quarter of the matches. If we were worse than random chance, then we would expect to win much less than a quarter of the matches. Okay, so something that we've talked about a bit is the idea of sampling variability. So if we have our sample of 50 matches, would we win exactly 25% of those matches, even if we assume that that the matches are decided by random chance, and so that we're therefore evenly matched? The answer to that is no. So there's sampling variability means that our sample proportion, which we've been denoting as p hat, can vary from one sample of 50 matches to another. So even if these matches are decided by random chance, we're not going to expect our sample proportion to be exactly 0.25. And in fact, in a sample size of 50, that turns out to be impossible because 50 is not divisible by 4. So it would never be exactly equal to 0.25 in this particular context. All right, so one final kind of setup question is again asking us to think about stuff from section 1, thinking about what exactly our population is for this particular context. And we could think about our context or our population as maybe being all matches we play with these friends if no one improves. So if one of our friends improves or if we improve at this game, then our sample of 50 matches might no longer be representative. But if nobody really improves, then we could think of our population as being all matches that we could hypothetically play with these friends. All right, so I think I'll pause that video there. And so in the next video, we'll do a little bit more prep and introduce the formal hypotheses that we will be testing.